subtract mixed numbers. I want you to follow along as I undo each box and each step. And if you need to write down something to help you remember something, then you can do that. Okay? Subtracting mixed numbers is almost the same as adding them. Okay? Almost. Hey, just do the best you can. The only difference is that you might need to borrow. Because when we do main subtraction, regular oral subtraction, don't you sometimes have to borrow? So the problem is that borrowing with fractions is different than borrowing with regular numbers, because fractions are not what we call base 10. You know, whenever you borrow, actually I'm going to give them fill that one. Whenever you borrow in normal subtraction, you're borrowing a 10, right? Well, fractions don't work that way. It's like time, an hour. If I wanted to borrow an hour, you have to give me 60 minutes, right? Not 100. If I wanted to borrow minutes and seconds, it's 60. If I want to go like borrow a foot, it's 12 inches. Okay, not 10. Or if I want to borrow, yards and feet, it's 3 feet to 1 yard. So if I want to give you a yard, I'm actually giving you 3 feet, not 10. Okay? So, exactly. But do you see how you're still borrowing, but you're not borrowing with a 10. Well, fractions basically are the same thing, because it all depends on the denominator, how many pieces I'm giving you. Right? It all depends, like, if I have 4 over 4, isn't that the same as 1?
Yes.
5 over 5, isn't that the same as 1? Well, if I'm borrowing from this one, I'm going to get 4 pieces. If I'm borrowing from this one, it's going to be 5 pieces. It's all based on the denominator. All right? So you have to look at those denominators to know how to borrow. But it's not as hard as you think. And I can tell you, when we get all done and we understand how it works and why it works, I'm going to give you a little trick, a little strategy to help you make sure that you get the answer right. So first of all, though, whenever we add or subtract any kind of fractions, the first thing you have to do is have a common denominator. Okay? We got to do it. So we are rewriting, and we do that first. We don't worry about subtracting. We don't worry about borrowing. We don't worry about anything. We worry about denominators first. Then we move on to subtracting the fraction first. Remember yesterday I told you how we want to keep in that habit of going fraction to, right to left? The problem is if you did the whole number first and then the fraction, what if you had to borrow? Right? So you do the fraction first, so then if you have to borrow, you can go over here and make the changes and come back. And then when you're done, you can do the subtraction. So we're subtracting our fraction, but if our top fraction isn't bigger than the bottom fraction, we've got to rename it, which is basically like borrowing. So if I'm doing like 1/8 minus 3/8, can't do that. At least not until we learn negative numbers. So we have to do some borrowing. Okay? After we've done all that, we've subtracted our fraction, and when we've subtracted our whole number, we subtract our whole number. Okay? Remember, too, when you borrow, don't you have to cross off where it comes from and change that number? Okay? You have to make sure you remember to do that. Then, when we're all done, we know everything with the answers, we have to simplify our fraction, making sure it's simplest form, making sure that if we have to recopy, we don't forget that whole number. You know the drill, right? Remember that checklist we worked on yesterday? So you have to make sure always your answer is in simplest form. Okay? So really, overall, it's not that much different, except the little borrowing piece and the fact that you have to subtract, which some of you got to keep that, because eventually we're going to mix them together, and you're going to have to remember to pay attention to the signs.
Adding weight in here.
Well, it is, but... All right, so let's take a look at the next page, the Let's Try It page. Okay? Now, I want you to write where I write, what I write. Okay? I don't want you to take any shortcuts, because I want you to later be able to figure out exactly what we did. So let's try it. I have 3 3/4 minus 2 5/8. Now, step 1 on our chart on the previous page says we've got to do what before we do anything else? Mia? That's right. We have to have a common denominator. We don't need to worry so much about the whole numbers, right? But we've got to write the fractions. So here's step number 1. Rewrite them so they have a common denominator. We're going to work right here. Okay? I'm going to bring over, for this problem, I'm going to bring over my whole numbers. What are we going to use for my common denominator, Chris? 8. Remember, we could use 24, we could use 32. But what is my step? Remember, first step is check to see if you can use the bigger one. No. Yes, we could. You're right. But we're going to use 8. Okay? So 4 times 2 is 8, so 3 times 2 is 6. So we're writing that down. Okay? That's what, we're not quite there yet. That is what you have to do first. Don't worry about whether or not you can subtract yet until you change all the numbers. Okay? You can't make any decisions until you have the numbers, everything in common denominator. Now, can I do 6 minus 5? Yes, I can. 6 minus 5 is 1. Our denominator is 8. 3 minus 2 is 1. Can I reduce any more? No. So that is our final answer. So that was step 2. Fraction first, then whole number. Did we need to rename there? Did we need to borrow? No, not on that one we didn't. Okay? So there are times, and there will be some on your homework, where you don't have to borrow. Okay? You have, just like in any subtraction problem that I give you, you might have in math. Sometimes you got to borrow, sometimes you don't. And you just have to know when. Okay? First thing we're going to look at is, if you have one whole number, I'm going to rewrite this problem sideways so you can see, horizontally, you can see what I mean. The first one is a whole number. You don't need to do that unless you feel a need. Okay? What do we do if the first one is a whole number? Okay? There's no fraction here. Well, in actuality, what fraction is there, Jason?
6.
Well, before that. Saying 0 what? No, 8. Right? Write that on your paper. Okay? In actuality, I have 7 whole pizzas and nothing sliced into 8s. All right? We just don't write it there. We don't need to write it. We don't want to confuse ourselves. But that is what's there for the moment. Yep. Can I do 0 minus 5? No. So I have to, and think about this, if I have 7 whole pizzas that haven't been cut yet, can I take out like 5 individual slices? No. But so that means I have to cut. Yeah. And that is essentially what we're doing when we borrow. Okay? So we're thinking about this number 7 as 6 plus 1. I'm going to leave 6 of my pizzas whole, and I'm going to take 1 pizza and cut it. Now, I'm cutting it into, in this case, 8 slices, because that was my denominator. 8 slices, 8. So 7 is the same thing as 6 plus 8 over 8. This is why we call it renaming. They are the same. 7 is the same as 6 plus 8 over 8. So, on our problem, we're going to change the 7 to a 6. So do that. Put it away and be with me. Okay, because remember, I can't give you something unless I take it away. I can't give Maddie one of Braden's pencils until I take it away from him, right? I can't give it to her if I don't have it. Same with this. You've got to take it away first. Make sure that you remember to do this first. Cross it out, take it down 1. Don't forget, otherwise you're going to have the wrong whole number. Now, we're going to take these 8 8s, and we're going to put them in here, and we're going to add them to what we've already got. Well, we didn't have anything, so now we have 8 of them, right? At this point, because this was a whole number, it's going to change once we get to fractions. Okay, put it here until class is over. Okay, so 8 minus 5 is 3. Denominator of 8. 6 minus 2 is 4. All done, right? I can't simplify. All right? I'm sorry. Fractions just lend themselves to pizzas. I know. All right, so let's look at the practice one. This is 5 5 minus 3 2/3. All right? I don't have any fraction here to subtract from. So I basically have 0/3, so I have to go next door and borrow. So we're going to rename this 5. What is 5 for this problem? Mr. Bowman?
4 plus 3/3.
Yes, it is 4 and 3/3. Well, last time I used 8/8. This time I used 3/3 because that's what my denominator is. If it was a 7, I would use 7/7. Because it's one whole. Now can I subtract? Yep. 3 minus 2 is 1. 4 minus 3 is 1. Am I done? Yes.
You are.
Okay? So that's how you do it if you have, the first one is a whole number, which actually, I don't think you have any of those on your homework, but you might. I don't think so. But you will eventually. Yes, Braden?
I actually don't really understand.
Good. Good. Okay, next page. Shh. Okay, turn around, pay attention. We need to get this finished. The difference here is now I have 2 mixed numbers. Okay, remember in the one before you only had a whole number? All right, it's the same process. First thing we got to do is make sure they have a common denominator. What am I going to use here, Caitlin? 6. So that's going to stay 1/6. This is going to become, this is times 2, so 3 times 2 is, 4. 3 times 2 is 4. Okay, so now I have 11 and 1/6 minus 5 and 4/6. Can I do that? No, I can't do 1 minus 4. So I need to rename or borrow. So we're going to think of 11 as 10 plus 1, and we're going to take that 1, and we're going to change it to what? What is my fraction going to be this time, Emily? 6/6.
Oh, I get it.
Okay, so this is going to become 10 and 6/6, and we're going to take that 6/6 and put it here. Now, I want you to think, and I apologize for the pizza reference again. Think about this for a minute. I have a buffet at my party. Okay. I'm sorry.
Even worse.
I have a tray of pizza. Okay. Come on, focus. You guys have lunch here shortly. Just focus. On all my pizzas that I'm using are going to be sliced into 6. All right, and I need to keep my tray refilled. So right now, I have a tray, and what's left on it is 1 piece on my tray. So I'm going to go back to the kitchen. I'm going to take one of my pizzas, cut it into 6, and put that on the tray along with my 1 piece. That's still there. So now, how many pieces do I have on that tray? Colton? 7. Well, yeah, I have 7, 6. I have 7 pieces, and each piece is a 6. All right? You cannot forget that 1 that was already here, and you're adding more to it. So this 1/6 is now going to be 7/6 because I take this 6 and I add it to the 1. So now I have 7/6. All right? Makes sense? Okay, you can't forget that 1 you already have. You don't want to throw it away. You need to add to it. Can I do 7 minus 4 now? Yeah. 3. 10 minus 5 is 5. Am I done? No, I have to divide by, no.
2, 1, 3.
Divide by 3. Okay, now remember, you cannot just write 1/2. You can't forget the whole number. It's 5.5.
5.5 pizzas.
Whatever. Okay, shh, stop. All right, let's take another, look at another one. 12 and 1/4 minus 10 and 3/8. First thing we got to do, make a common denominator, and we're going to use 8. So this is 2 8s. What? I have no idea. I made this a long time ago. Huh? The middle one?
Oh.
Can I do 2 minus 3? No. Gotta borrow. Gonna go to this 12, and it's gonna become a 11, and we're going to add 8 eighths to this. So we have 2, we're adding 8 more, so now I have a total of 10 eighths. Now can I subtract? Yep, 10 minus 3 is 7, denominator of 8. 11 minus 10 is 1. Now I want you to look at something for a minute. I want to see if you notice a pattern. Everybody, first of all, understand about borrowing and how we're taking something and cutting it and adding it to what's already there. Okay? And you know why. You see why. Now, I want to teach you the trick. Okay? It's a strategy, but you have to know why it works, which we just explained why it works. Take a look at when I borrowed here. I had a 1, right? And I added 6 more because 6 was my denominator. So I took my denominator and I added that many to my numerator for my new numerator. On this one, I took my denominator, because I had 8 things, and I added that many to my numerator to get my new one. You see my pattern? Did you see what I did? I'm adding my denominator to my numerator to get my top. Okay, right here, I added 6 plus 1 as my new numerator.
Oh, that's like a trick.
It's a trick, it's a strategy, yes. And it makes sense, because every time you get one whole, it has to be the same as your denominator. So that's how it works. That way you don't ever have to forget about, or remember about which ones exactly to add, if it's 3 over 3 or 4 over 4. If you just add the denominator and numerator and make that your new numerator, you have what you need. Emily?
Will everything brown when you add that?
It shouldn't be.
Okay.
Shouldn't be. Yeah, unless you do it wrong. All right, let's look at the last 2 on the bottom. We're going to use that strategy this time. You may need to touch this one up a little bit. Yeah, again, these are old, and I made some mistakes, and I guess I never went back and fixed them. Not a biggie. It's 6 2/5. So just finish the. Oh wait, it's not plus, is it? We're doing subtraction, aren't we?
Yeah.
6 I know you need to put it on yours. Fix that problem so it looks like mine. Add the negative or the subtraction sign. Add the answer bar. I don't know. So 6 2/5 and 2 5/8. What are we going to use for a common denominator, Alex?
I'm thinking 40.
Yep, you're right. We're going to use 40 because that's about as good as we can get. So 5 times 8 is 40. So 2 times 8 is 16. So that's my new fraction here. Right? Everybody with me there? 8 times 5 is 40. So 5 times 5 is 25. So there's my new fraction there. Okay. Can I do 16 minus 25? No. Okay. So we've got to figure out what my new numerator is here. Well, if we use the strategy of adding the denominator to the numerator, because we know we're going to get 40 40ths, what's 40 plus 16? 56. Now you could go over here and do it if you needed to, but this one you should be able to actually do like 6, 5, and get it figured out right from. In other words, you could do that in your head unless there's a lot of borrowing involved, and then I better see a side problem. Okay? Now, can I do this? Oh wait, what did I do wrong? What did I forget to do? Mia? Yep. I forgot to take that 5 away, that 6 away, or the 1 away from my 6, because I can't give it to here until I take it away. So now I have 5 and 56 40ths, which, Jason, is 6 minus 5 is 1. What's my answer?
I was going to find out that you didn't have a 40 out of the 56. Yeah.
Well, it's right there.
Oh,
I'm kind of cheating.
oh,
56 minus 25 is 31 over 40. When I'm doing that, I'm basically doing this and just alternating a fraction. And 5 minus 2 is 3. Let's see. Oh, it's not improper. It's not even. I don't think there's anything we can do with 31 and 40, so I'm pretty sure we are done. Stop. Okay, Brayden, Emily. Huh?
You already finished this. Oh, 5. Oh, there it is.
3 and 31 Okay, you need to follow with me, and you guys need to pay attention. Okay, let's do the last one. 3/8, 3/4. Kyle, what are we going to use for common denominator? The best choice. Remember, always check the bigger one. That would work, but what would be a better choice? 8. Yep, in this case, we can use the 8. Oh, wait. In this case, we can use the 8 because 4 times something goes into 8. Remember, I want you to try to use the bigger one if all necessary. Or, yeah, if at all possible, excuse me. So, 4 times 2 is 8, so 3 times 2 is 6. So now I have 21 3/8 minus 11 and 6/8. Can't do that, can I? Can't do 3 minus 6. So we're going to borrow from our 21. Always do that first. Otherwise, you're going to forget like I did. 21 becomes 20. And we're going to add our denominator and numerator because we're going to add 8/8. So 8 plus 3 is 11. So now we have 11/8. Now can I do that? Sure can. 11 minus 6 is 5. Denominator of 8. 20 minus 11? 9. Again, if you can't do that in your head for some reason, if it's something a little harder, I better see some side work, okay? Don't be trying to do stuff in your head that requires borrowing and carrying, okay? I don't want you to mess it up. Oh, am I in the simplest form here?
Yeah.
Yes. Yes. If that were 4/8, would I have been? No, it would have been half. Or 2/8, we had to change it, or 6/8. Questions? Not so bad, is it? Nope. All right, put these in your binders. If you need to leave them out to refresh your memory, like you can leave your binder open, and I will pass out tonight's homework. They are written sideways, but you can feel free to write them vertically or whatever helps you. You can use the back. You can use another sheet of paper. There's 12. When you're all done, I want the final answer in simplest form, not only here somewhere, but over here on the lines, okay? Some of them you'll have to borrow, and some of them you won't. You have to use your brain to figure out which one. Then I guess you're in trouble, huh? If your brain doesn't work, you're in trouble. You have to make that choice. You have to use what you know. You guys have 5 minutes. Get busy.